All right, let's give this another try, and I'm going to start number 3 because I did not do this correctly. There is one choice and one choice only. It is true that an identity is what we are eliminating, but we're also eliminating problems that are not identities. So if we look at A and we distribute the 2/3, we get 2/3 x plus, and 2 times 6 is 12 divided by 3 is 4, which is equal to 2/3 x plus 4. That is an identity, so answer choice A is not our answer. But if we look at C and D, here if we distribute the 4/5, we have 4/5 in plus 4/15 is equal to 4/5 in plus 1/3. And what I didn't notice about this is if we subtract 4/5 in from both sides, this reduces to 4/15 equals 1/3. And that's just not true. These are not equal. So no matter, because the terms within cancel each other, it doesn't matter what value we pick for n. It's got to be the same value on both sides. And because these subtract out or eliminate each other, we have a fundamentally false statement here. There is no solution to C. So we would say no solution. We're looking for one with exactly one solution. It's not C. A again was an identity, so there are infinite solutions to part A. C, there are no solution, and D happens to be no solution as well. If we look at this one, 7/8 times 2 is 14/8, so we have 14/8 t, plus 7 times 1, 8 times 8, so 7 over 64 is equal to 7/4 t. And what I didn't notice here is 14/8. If we divide the top and bottom by 2 and reduce, we get 7/4 t. So we have 7/4 t plus 7 over 64 is equal to 7/4 t. And again, we can subtract 7/4 t from both sides, and that goes away. This goes away, and we get 7 over 64 is equal to 0, which of course again is not true. I should have used a not equal to, right, because those aren't equal to. This is not true as well. So no matter what t is equal to, there's no value of t that will make this equation true, so there are no solutions to this one either. So the only possible one is this one. And if we do solve this, we would add 3/7 to both sides, and so 3 plus 3 is 6. We get 6/7 y is equal to, and then subtract 13 from both sides, so that 13 goes away, and 13 minus 13 on the right is 0. We get 6/7 times y is equal to 0. This does have a solution, and the way to find that out is to multiply both sides by 7/6, and the 7's cancel, the 6's cancel. We get y is equal to 0 times 7/6, which is y is equal to 0, and that is exactly one solution. There's only one answer that works for this, and that is y equals 0. And you can see if we let y equal to 0, these terms go away, you get 13 equals 13, which is true. So y equals 0 does satisfy this equation, and it's the only value that satisfies this equation, and therefore the only answer choice that has exactly one solution is answer choice B. Okay. So the rest of this is to make up for the lost recording that we attempted this morning, so hopefully this will work. So here the perimeter of the square is equal to the perimeter of the triangle. So the p of square is equal to p of triangle. The perimeter of the square is going to be the distance around the square. We see that one side is 3x plus 3, so the entire perimeter would be 4 times 3x plus 3. That has to be equal to the sum of all 3 of these sides of the triangle. So 2x plus 7x plus 7x. 7 and 7 is 14. 14 and 2 is 16. We get 16x And then if we add -2 plus -2, that's -4 plus +4 is 0. So we have plus 0 there. We're actually solving this equation. 4 times 3x plus 3 equals 16x. So we distribute the 4. 4 times 3 is 12. Again, 4 times 3 is 12. All right, this is 12x. So we have 3x equals 16x. And so we can subtract 12x from both sides, and we get 12 is equal to 4x. And now we can divide both sides by 4, and we get x is equal to 3. So the question was, what are the side lengths of the square? So if we know that x is equal to 3, the square has side lengths of 3 times x plus 3. So when x is equal to 3, we got 3 times 3 plus 3, which is 9 plus 3, which is 12. So the side lengths are 12 units of length long. Here the formula d equals r over t relates distance, rate, and time. Solve the formula for t. So if we have distance equals rate times time, to solve for t, we want to divide both sides by r. This way the r cancels, and we're left with t is equal to d over r. So that would be answer choice G. T is equal to d over r, or d over r is equal to t. Equations are reversible, of course. So this is one form. Our d equals rt is another form relating these three. And of course, we can also divide both sides if we wanted to by t, by time. That way the time cancels, and we get r is equal to d over t. So d over t is equal to r is another version of this equation. So if you have any two, you can solve for the third in distance, time, and rate equations. Remember, rate just means speed. Speed is a rate. When the rate, a rate is a ratio, and when the ratio is between is distance divided by time, that's a speed. Okay, so look at the next one here, number 6. Hopefully that was on the screen. Oh, I have to make sure that was on the screen. Hopefully I wasn't writing off of the screen. I think I was. Yeah, I think I was writing down here. I did that whole problem off screen. So be careful about that. Okay, live and learn. So, try to not let that happen. 6. What is a possible first step to solve the equation 3x plus 5 equals 2 times x plus 7? Multiplying the 2 in to get rid of the parentheses so that the right side becomes 2x plus 14 is the possible first step, and that's called the multiplicative property. That's called the distributive property of multiplication. So we can use the distributive property of multiplication to distribute the 2, multiplying it by each term, and get rid of the parentheses. So multiply the x by 2 and the 7 by 2 is what we did. Number 7, you work as a sales representative. You earn $400 per week plus 5% of your total sales. 5% is 0.05. So if we let our total sales for the week be equal to S, and if we let our total earnings be equal to Y, then our total earnings will be equal to this flat $400. That is our total earnings in 1 week, Y, will be equal to this $400 that we get no matter what, plus 5% of all the sales we do, so 0.05 times S. So this is going to be our master equation for answering these part A, B, and C. Part A says last week we had a total sales of 5,000. So that is S equal to 5,000. So if S is equal to 5,000, find our total earnings. So find Y. So if S is 5,000, find Y. So y would be equal to 400 plus 0.05 times 5,000. And we did that. So let's multiply 5,000 by 0.05. 5 times 0 is 0, 5 times 0 is 0, 5 times 0 is 0, 5 times 5 is 25. Count the decimal places, 1, 2 to the right, so to the left. So 1, 2, move the decimal place 2 places to the left, and we have 250. So 400 plus 250 is 650, and that will be our total earnings. So $650. Part B says 1 week we earned $1,350. Let S represent your total sales, and for that week, and then write an equation that you can use to find S. So if Y is equal to 400 plus 0.05 S, and our total earnings were $1,350, that means Y is equal to 1,350. And if we want to solve for S, for our sales, we have to solve this equation for S by first taking 400 away from both sides. So 1,350 minus 400 will be equal to 0.05 S. 1,350 minus 400 is 950, so 950 is equal to 0.05 S. Then we have to divide both sides by 0.05. So 5%, right? So the 0.05s cancel. We get S is equal to 950 divided by 0.05. And so to divide 950 by 0.05, we move the decimal place over 1, 2 places. So 1, 2, we fill the zeros in. We move the decimal place up, and we ask how many 5s in 9? 1. Subtract. Bring down the 5. How many 5s in 45? 9. 9 times 5 is 45. Subtract, we have 0. Bring down the 0. There's 0 5s in 0, 0, 0. Bring down the 0, 0. Make sure our place values are lining up. We've got to be careful when long dividing, right? So we need one more 0 here. And now this is 19,000, remainder 0. 19,000 is our sales. 19,000. And that's the answer to part B. The answer to part B is write an equation. I got a little ahead of myself, so part B would be, the answer to part B would be our equation for the sales, which would be 950 divided by 0.05, and then the answer to part C would just be this, the answer to that division problem. So that would be our $19,000. Okay, number 8. In 10 years, your aunt will be 39 years old. Let M represent her age today. Which equation can you use to find M? So if M is the age today, if we add 10 years to that, then our aunt will then be 39 years old. So that's all we're looking for. M plus 10 is equal to 39. Number 9. There we go. Which value of y makes the equation 3y plus 8 equal to 7y plus 11 true? That is, let's just solve this equation for y. So we're going to subtract 7y from both sides. We're going to subtract 8 from both sides. 3 minus 7 is negative 4. 11 minus 8 is 3. Divide both sides by negative 4, and we get y is equal to negative 3/4, which is negative 0.75. Answer choice B. What is the value of x given the fact that these two angles form a 90-degree angle? So 2x plus 12, whatever the degree, whatever the measure of this angle, when we add it to the measure of this 32-degree angle, they have to add up to a right angle, which is 90 degrees. So we just want to solve this equation for x. And that's it. Yeah, value of x. So 12 plus 32 is 44. So 2x plus 44 is equal to 90. Therefore, 2x is 90 minus 44. So 2x is, that's going to be 46. And so divide both sides by 2. We get x is equal to 23. So answer choice F. The number 11 here, you have already saved $35 for a new cell phone. You need $175 to buy the cell phone. You think you can save $10 per week. At this rate, how many more weeks will you need to save money before you can buy the new cell phone? So the $35 that we already saved, plus the money that we save every week, which is $10 per week. So x would be the number of weeks we're saving. $10 each week. We'll multiply x by 10. We want that to be enough to cover the cost of our cell phone, $175. So that's the equation we want to solve. So we subtract 35 from both sides, and we have 10x is equal to 140. So x is 14. Right. So after 14 weeks, we'll have enough to buy our cell phone. Number 12, what's the greatest angle measure in this triangle? The sum of the measures of all angles in a triangle, all three angles in a triangle, is always equal to 180. That is always true for all triangles. So 3x plus 2x plus 50 has to be equal to 180. That's the equation we want to solve. So 3 plus 2 is 5. We have 5x, combining like terms, is equal to 180 minus 50. Right? Subtract 50 from both sides. So 5x is 130, which means x is, well, 130 divided by 5. So 2 times 5 is 10. Get 30. 6 times 5 is 30. 26. X is 26. But that's not enough to answer our question, what is the greatest angle measure? We have to calculate the measures of each angle by evaluating the expression. 3 times 26 would be 78. So this is a 78-degree angle. 2 times 26 is obviously going to be less than 3 times 26, so anyhow, that would be 52, and this is a 50-degree angle, so clearly 78 degrees is our largest angle here, our greatest angle. Number 13, which value of x makes this equation true? So we're going to solve this equation. So we're going to distribute the 6 to both the x and the negative 3. We get 6x minus 18 is equal to 4x minus 7. We're going to subtract 4x from both sides. So 6x minus 4x is equal to, and then add 18 to both sides. So negative 7 plus 18. Do I have a pencil sharpener here? Way over there. Excuse me a moment. Okay, 6 minus 4 is 2, so 2x, and then negative 7 plus 18 is the same as 18 minus 7, so it's 11. Divide both sides by 2, and we get x is equal to 11 over 2. 11 over 2 is 10 and a half, and 10 and a half is 10.5. So that is not, 11 over 2 is not 10 and a half. See what happens when you sharpen pencil? 11 over 2 is 5 and a half. Alright, when in doubt, just do the division. 5 and 1/2. Alright, so that's 5.5. Alright, so answer choice I. It's positive 5.5, not negative 5.5. You need to be careful with your signs. Okay. I'm double checking to make sure. Yes, because we kept the x terms on the left, and 4x is 4 is less than 6, so 6 minus 4 is positive 2. Okay, so number 14, the drawing below shows the equal weights on two sides of a balance scale. We've got trophies and mugs. So we'll let x be the weight of a mug, and we'll let y be the weight of a trophy. Sorry, I may have done this the other way around when we did it this morning. By the way, we've got on the left, so if they're equal, the weights on the left and right are equal. There are 3 mugs on the left, so 3 times x, plus 1 trophy, so plus y, is equal to 2 trophies, the weight of 2 trophies. So if we subtract y from both sides, we get 3x is equal to y. And remember, y is the weight of a trophy, x is the weight of a mug. So the trophies weigh 3 times the weight of the mugs. But that option isn't available. If we divide both sides by 3, we see that the weight of a mug is the weight of a trophy divided by 3, which is to say 1/3 of the weight of a trophy. That answer is here. A mug weighs 1/3 as much as a trophy. Okay. Is that on screen? I hope so. I think so. Alright, that's cumulative review or practice for chapter 1. Chapter 2, we're looking at a clockwise rotation of 90 degrees. Oops, here we go. And asking what is the equivalent to a counterclockwise, or a clockwise rotation of 90 degrees is equivalent to a counterclockwise rotation of how many degrees? So a rotation on an XY axis here in the clockwise direction. Remember, clockwise, a rotation is in this direction. A counterclockwise would be in this direction. And so if we take a point, say on the positive x-axis, and we rotate it clockwise by 90 degrees, that will put the point over here. That's a 90-degree rotation. Right, there's your 90-degree angle. Now to get that same point with a counterclockwise rotation, we have to rotate 90, 180, 270 degrees. So a 270 degree counterclockwise rotation is our answer. Gives us the same rotation as a 90 degree clockwise rotation. Number 2, the formula K equals C plus 273.15 converts temperatures from degrees Celsius C to kelvins K. Which of the following formulas is not correct? So I showed you one way this morning. I'll show you another way. Now the other way is simply to solve for K in each case, and if we have a match, then it is correct. If we don't have a match, then it's not correct. So we're looking for the one that's not correct. So to solve for K in each case, to solve for K here, we would have to add C to both sides. So if we did that, we would get K is equal to 273.15 plus C, which is the same as C plus 273.15. So this is correct. A is correct, which is to say it's not the correct answer because we're looking for the one that's not correct. Okay. If we solve for K in part B, we would add 273.15 to both sides. And if we add 273.15 to both sides, it goes away on the right, we get C plus 273.15 is equal to K. And that's the same as K is equal to C plus 273.15. So that's a match as well, which means it's not our answer. Then if we solve for K here, we could add K to both sides, and we would get C c is equal to, alright, because negative k plus k is 0. C is equal to negative 273.15 plus k. And if we compare this to our answer, we're solving for k, not c. We're not done yet. And so we would then add 273.15 to both sides to solve for k. And that would cancel. 273.15 cancels on the right, and then we would have c plus 273.15 is equal to k, which again is a match. So it's not c, which means it's got to be d, but let's make sure. If we solve d for k, we would have to subtract 273.15 from both sides. And so we would get c minus 273.15 is equal to k, or equal to k that way. And that's clearly different than c plus 273.15. So this is not correct. So our answer choice is D, the one that's not correct. Okay, so number 3, you want to solve this equation. What should you do first? Math is math is amoral. It's not moral. So the should is not a moral should. It's more of a elegant. What is the sort of easiest step maybe to solve this? Because there are really two things you could do to start with. You can distribute the negative 3 and get negative 3x minus 6 is equal to 12x. Or, let's bring it over here, you could divide both sides by negative 3. And by dividing both sides by negative 3, the negative 3's on the left cancel because this is multiplication. And so you're just left with x plus 2 on the left. And then on the right, 12 divided by negative 3 is negative 4. So on the right, you just have negative 4x. And so we're basically given a choice that leads to either this equation or this equation. And this is sort of a simpler equation after making the choice of dividing both sides by negative 3. So this is sort of a more elegant solution, if you will, more elegant way to do it. This is perfectly fine. We can do it this way as well, and we'll get the same answer. In fact, if you divide each term here by 3, we get negative x minus 2 is equal to 4x. And compare this to this. If we multiply both sides by a negative sign, either this one, multiplying both sides by a negative, we get that one. Or if you multiply both sides of this by a negative 1, we get this. So these are the same equations, really. So just to show you that. But our answer choices, we're limited by our answer choices. And the one that matches, the only one that matches one of the two methods is this: divide each side by negative 3. Okay, number 4. Which value of x makes the equation 3/4 x equal to 12 true? So again, this is you have sort of options here. You can write it as 3x over 4 equals 12 over 1, and then set the cross products equal. So 3x times 1 is 3x, multiplying diagonally this way. And then 4 times 12 is 48. And this gives you x equal to 48 divided by 3. Right. And that's 16. So you can get it that way, or you can notice that when use the property of fractions, that when we multiply a fraction by its reciprocal, we get 1. So 4/3 is the reciprocal of 3/4. So if we multiply 3/4 by 4/3, which is to say multiply the entire left side by 4/3, 4/3 times 3/4 will give us 1. 4 over 4 is 1, 3 over 3 is 1, 1 times 1 is 1. We get 1 times x, or just x. That means we have to also multiply the right side by 4/3. And 12 times 4 is 48. 48 divided by 3, as we saw over here, 16. Or you could also take the 12 divided by 3 first. 12 divided by 3 is 4, and 4 times 4 is 16. So you have that option whenever you're multiplying a fraction by a whole number. You can multiply the numbers on the top and then divide by the number at the bottom, or you can take the whole number divided by the denominator and then multiply it by the numerator, right? By the way, you get x is equal to 16. Number 5 here, triangles graphed on the coordinate plane. What are the coordinates of the image after a translation of 3 units to the right, 2 units down? So we take each point, move each point 3 units to the right and 2 units down. So A becomes A prime here, 3 to the right and 2 down. B, 1, 2, 3 to the right, 2 down, moves down here to B prime. C, 1, 2, 3, 1, 2, moves down here to C prime. So we have our new triangle. This is a translation, which simply means a shift, left, right, up, down. No rotation, no reflections. A translation is simply shifting, sliding it over, if you will, or over, up, down, left, right. So what are our new coordinates? A prime is now at 1, 2, 1, comma 2. If you look at the possible choices for A prime, the only one that matches is going to be G. So if you're pressed for time, just circle G and move on. But just to verify, B prime is at 1, negative 1. That's correct. C prime is at 3, negative 1, 3, comma, negative 1. And so that's correct. All right, then number 6. Your friends, here we are. Your friend solved the equation in the box shown. What should your friend do to correct the error? And so when we did this, we verified all these steps were correct until that last step, because if you take it from here, 3 times negative x over 3 is like 3 times negative 1/3 times x. And 3 times negative 1/3 is negative 1. You get negative 1 times x, which is negative x. This side, from there to there, is correct, because 3 times 13 over 15 is 2 3/5. We want to make sure to verify that, right? 3 and a positive times a negative is a negative. They have the negative there. But 3 times 13 over 15 is the same as 3 over 15 times 13. And 3 over 15 reduces to 1/5. So 1/5 times 13 is 13 over 5, which is 2 3/5. So the 2 3/5 is correct. What's wrong is that they should have put a negative sign here, but that's not an option. So our option, we have to go back a step and say, well, instead of multiplying by positive 3, if we multiplied both sides by negative 3, then this would become a positive x. And this then would become a negative times a negative, which would then be a positive. So we would, this is the correct answer, x equals positive 2 3/5. And so we could have multiplied by a negative 3 at this step, which would have been a better choice than multiplying by a positive 3. And so that would be either B or C, multiply each side by a negative 3. But we see that if we did that, we would get x equal to 2 3/5, positive 2 3/5, which would be this one. Alright, what is this? X plus 2/5 equals 7/5. Where is that even coming from? I'm not sure, but that's not the right answer, because if we solved for x here, we'd have 7 over 5 minus 2 over 5, which is 5 over 5, which is 1. That's not what x is supposed to be equal to. Alright, now number 7. Your teacher dilates, and remember we discussed that dilate means either enlarge or shrink in a shape. Here we have a rectangle, so we're dilating it using a scale factor of 1/2, since a half is less than 1, we're multiplying each side by a number less than 1. So we're shrinking this. So 6 divided by, or 6 times a half is 3, 10 times a half is 5. And so when we dilate to the new shape, it's going to be a rectangle with a height of 3 and width of 5. And we're asked what is the area of the dilated rectangle in square inches. So 3 times 5. Base times height. Area is 5 times 3. Right, for a rectangle, area is always base times height. We have the base of 5. Base of 5, a height of 3. So 15. So area is going to be 15 square inches for our dilated shape. By the way, what's the area of the large one? 6 times 10. That's 60 inches squared. So we went from 60 inches squared to 15 inches squared by halving the lengths, half the lengths. So we halved the lengths, but the area was quartered. 60 divided by 4 is 15. So we quartered the area. So when we scale down a figure and reduce all the lengths by a half, the actual area inside goes down by a quarter, by 1/4. There's 1/2 squared. That is 1/4. Okay, the number 8, your cousin earns $9.25 an hour at work. Last week she earned $222. How many hours did she work last week? So this is simply her hourly rate, $9.25. Oops, not $9.95. $9.25 times the number of hours she works, so let that be equal to X, equals her total earnings, $222. So we're going to divide both sides by 9.25. So this is really just a division problem. I don't know if you can hear all that noise outside, but they are loud. Okay, transition time is here. So we cross out 9.25. We get X is equal to this quotient. We have to divide, so let's do that somewhere here. How about 222 divided by 9.25. So remember, in long division of a decimal, we're going to bump that over 2 decimal places. Do the same here, but we need zeros to fill those spaces in. Then the decimal moves over there, and we move that up. So this is like 925 into 22,000 now. Well, 925 doesn't fit into 222, so we go one place value over 2,220. 925 is close to 1,000, and there are 2,000s in 2,000, so we're going to say this is going to be close to 2. Since we moved one place value over, we're going to write our 2 right over that last place value that we're using. So 2 times 5 is 10. Carry the 1. 2 times 2 is 4 plus 1 is 5. And 2 times 9 is 18. Subtract. 0 minus 0 is 0. We need to borrow. 12 minus 5 is 7. We borrowed from the 2. It becomes a 1. We need to borrow again. So 11 minus 8 is 3. We borrowed from that 2. 1 minus 1 and then 0. So we bring the we bring this 0 down and ask how many 925s into 3,700. And again, 925 is very close to 1,000, and there would be 3,000s in 3,700, but almost 4,000, because 3,700 is very close to 4,000. So let's try 4, since 925 is just under 1,000. This might work out just perfectly. So 4 times 5 is 20. Carry the 2. 4 times 2 is 8 plus 2 is 10. So far so good with those zeros. 4 times 9 is 36 plus 1 is 37, and we get a remainder of 0. So 24 is our answer. 24 hours. The number 9 here. Oh, this is the fun one. Okay, so triangle EFG is a dilation of triangle HIJ. So maybe it's a little bigger, maybe it's a little smaller. Kind of looks, now that I look more closely, it's a tiny bit bigger. But that means that the ratios of corresponding sides of similar triangles are congruent. So HI compared to EF is going to be the same ratio as IJ to FG, the bottom to the bottom. If that's 1.5, if this is 1 and this is 1.5, that ratio of 1 to 1.5 would be consistent whenever we compare any side of the smaller one to the corresponding side of the larger one. So let's say if the base were twice the width of the right side, then the base of the larger one would be twice 1.5. So 2 to 3, for example, is the same ratio. So let's look. So EF to FG, if we compare EF, that's this side, to FG, that is this side. So we have the right side of the, I'm going to say larger, to the bottom of the larger. Comparing that to the right side of the smaller compared to the bottom side. IJ is the bottom. So, okay, right to bottom compared to right to bottom. Those ratios should be the same because this is a scale factor. We scaled all of the lengths the same amount. So that should be correct. So that's not our answer because, again, we're looking for the proportion that's not true. Let's look at B. EG compared to HI. So EG, I'm going to have to, I guess, erase. Okay. EG is the left side of the bigger one compared to HI. Oh, that's not the left side of the smaller. So this looks like it might be wrong. Let's see. FG compared to IJ. Those two sides are corresponding. They're both the bases of each triangle. So it looks like it's going to be B. So let's put this in parentheses for now. Let's eliminate C and D just for safe. So confidence, excuse me, erase this, just so that we can have confidence in our answer choice of B. So if you look at GE compared to EF, GE compared to EF. So left side of larger one compared to right side of larger one should be equal to the left side of the smaller one compared to the right side of the smaller one. So JH is the left side of the smaller one and HI is the right side of the smaller one. So left to right big equals left to right small. That's correct. Okay, so that can't be our right answer because we're looking for the one that's not true. And then finally, answer choice D. Here we go again. Alright, that's the dilation. If we compare EF, so that's right side of large, to HI, that's right side of small, so those are corresponding. To GE, so that's left side of small, to JH, that is the left side of, sorry, GE left side big, large triangle, compared to left side of small triangle. Those are corresponding sides, so those ratios should be equal as well, so it's definitely going to be B. Alright, number 10. The red figure is congruent to the blue. Congruent means same shape and size. That's in opposition to similar. The word similar just means same shape but different size. Well, I shouldn't say necessarily different size. All shapes that are congruent are also similar, but all shapes that are similar aren't necessarily congruent. Anyway, so a size can have, or two shapes can have both the same shape and size, or two shapes can have both the same shape and different sizes. But if two shapes have both the same shape and size, then those two shapes definitely have the same shape. So, in other words, if they're congruent, they're also similar, but if they're similar, they're not necessarily congruent. Alright, but these two shapes are congruent, so they're the same shape and size. You can see that the way they're drawn. The question is, which of the following is a sequence of rigid motions between the figures? Rigid motions. So a transformation. So going from red to blue, to get from red to blue, we reflect across the x-axis. So that is a x-axis reflection. That brings us here. And then we shift to the left by 3. So that is a horizontal shift of 3 to the left. So that's one way to get from red to blue. We could have also shifted the red 3 units to the left first, and then reflected this across the x-axis to get the blue. So we could have done this in reverse order and gotten the same transformation. The one that matches or gets us there, reflecting the red triangle in the x-axis, check, and then translating 3 units to the left, right, check. Okay, it looks to be F. If we reflect the red triangle along the x-axis and then shift to the right, we're going to be over here. That won't work. If we reflected the red triangle along the y-axis, that will put it way over here, and then translated it 3 units to the left, that would even be further over here. Definitely not that one. And rotating the red triangle 90 degrees clockwise about the origin. So a 90 degree, imagine just taking a copy of this, an overlay of it, and just rotating it 90 degrees. Our 1, 2, 3, 4 will be down at 1, 2, 3, 4. We would be down here with a triangle looking like this, and so that red one rotated 90 degrees clockwise would result in this one. So that's not the blue one either. Okay, number 11 here. Several transformations are used to, sorry, I'm seeing if I'm getting kicked out of the office yet or not. I don't think so. Several transformations are used to create the pattern. So describe the transformation of triangle GLM to triangle DGH. So we find those triangles. GLM is this one. DGH is this one. And we have moved up, we've translated up a certain distance, and that distance is the same as the length of this side, GL. So this is a upward translation, or a shift up, or translation up, however you want to use the technical word, translation up of GL. GL is the distance of this side. So we just shifted GLM up a distance GL to get to DGH. Part B, describe the transformation of triangle ALQ. ALQ is the big one, the largest one here, to triangle GLM. GLM is that bottom one, lower left. So we took the big one and we shrunk it down to the small one, and you can see that each side of the big one is 4 times the length of the small one. Since each of these are the same shape, we have 1, 2, 3, 4, 1, 2, 3, 4, and even along the diagonal, 1, 2, 3, 4, or the hypotenuse, I say. So to get from the big one to the small one, we basically take the large one and we multiply each side by 1/4. So scale factor, describe the transformation. We would say triangle GLM is a dilation of triangle ALQ of is a dilation of scale factor 1/4, or with scale factor 1/4. We should say 1/4, but 1/4 of a scale factor 1/4. When we say scale factor, what we mean is we multiply each side of the original triangle by this scale factor to get the side length of the transformed scale factor. So AL times 1/4 gives us GL, right? LQ, 1/4 of LQ would be equal to LM. Okay, part C. Triangle DFN is a dilation of triangle GHM. So DFN is this triangle in the middle here. That's a dilation of triangle GHM. So GHM is this white triangle, that smaller one. Find the scale factor. So just by knowing that, from DL, that's 2 times GL. So FN is the same distance as DL. So FN would have to be 2 times HM. And so if one side is 2 times, if the height of FN is twice the height of HM, the same is true for the widths. So DF, this segment here, is the same as 2 times GH. As a whole, the triangle, by the way, D, you can see it too, but DN is the same as 2 times GM, so that diagonal as well, right, is equal to 2 times GM. And so triangle DFN is a dilation of triangle GHM by a scale factor of 2, right? By a scale factor of 2. 2. Okay. That's our answer for part C. Okay, I think this is the last one. Number 12. A rectangle is graphed in the coordinate plane. What are the coordinates of the image after reflection in the y-axis? Remember, in means across the y-axis or about the y-axis. So you can use either across or about. I prefer these two to in the y-axis. Anyway, if we reflect this shape about the y-axis, then the y-axis is a mirror, and we reflect each point across that mirror. So L reflects across the mirror to this point here, to L prime. Point M reflects across the mirror over here to M prime. Point K reflects across the mirror. So how far away is it from the mirror? 1, 2, 3, 4 units to the left. So it's going to reflect across, and now 1, 2, 3, 4. After the reflection, it will be 4 units to the right of the mirror. So K prime will be over here. J prime would be underneath K prime. So there's our new shape. Those are our new coordinates. This is the reflection of the original shape across or about the y-axis. So we can see point J prime is going to be at 4, +1. So that's this one. And you can verify the other 2 points. All right, thanks. That's it. We got through them. Hopefully this recorded. All right, take care.